This is a very straightforward introduction to how to use the stamp function in a copy shop. What we're going to do is work with a box and a grid, and we're going to do that all in one geometry object. So in this case I'm changing to create in context. Over here I start with a geometry object and I dive inside and get rid of the file sub. I'll then call in a grid, and pretty much everything that we bring in as far as geometry we're going to leave as default. As I said, this is going to be a very simple demonstration. I don't need the construction plane visible, so I'm going to turn it off as well. Then the next thing to do is to bring in a box. Very quickly we can set up most of what we need to do here. So from the box I'm going to call in a copy shop and then plug the grid in to the right hand side, which is the template to copy the box to. And we get boxes copied to every point on the grid. The odd thing about the stamp function, which is here in the copy shop parameters, is that for the most part we have to work backwards. When we're doing something with the stamp function, we generally know what it is we're after. So at the end of the process, that's what we understand the best. So what we do is we set up the conditions in the stamp function that will be fed into it from, in our case, a transform shop from the box. Now it seems a little bit odd, but bear with me. I'm going to put in a transform shop here, and then set up the conditions for the stamp. So what we're doing is building local variables that we can identify and use in expressions in this transform. So let's start very simply. We'll work with scale, and we'll define that as a local variable. And the value for this is going to be a random function based on number of points, and then add a multiplier. So this is rand $PT, which is read the point numbers, times 8. This is the variable that we're going to use in our transform. And what we'll do is we'll just uniformly scale these based on our stamp function. So in the uniform scale we're going to use a stamp function. Then we need to read down to the copy shop call in the variable that we created, and then a small multiplier. Once we've done this, we can go back here, and the one thing I always forget to do is actually turn on the stamp inputs here. So once I've set this up here, I go back to the copies up. That's what the long pause is for. Turn on the stamp function. And we have this function delivering information back to the copy shop, and then running this value. So you see here, we don't have that random function in here. All we have is the scale. So in this case, even though we've set up this value first, what's actually happening is in the scale, the transform is saying send this information down to the copy shop, and because I'm acknowledging this scale variable, in the stamp function here, once I remember to turn it on, there's the scale, and it says run this value, and we get a multitude of boxes randomly scaled based on this value. So it's very easy to elaborate on this and just continually add variables, and you can see here we have lots of folders for lots of variables. So let's enhance this a little bit more. We'll create height. So let's call it that. Height. I don't want to, I'm going to use the same random value, $PT times 5 in this case, and then because I don't really want the objects too tall, I'll say multiply by 0.5. Now an oddity here is that the copy function changes the direction of the scale. So the scale is actually oriented along the normals, and the normals are really defined as reading along the z-axis. So when we're putting our height variable into the scale, in order for the height to work, we're actually going to go to the z-axis. Now, I'm going to cover just this aspect of the expression as we're typing it in. Houdini is intelligent enough to understand that if I'm building a path, and this dot dot is a path that leads out of the transform, and is suggesting that I'm looking for some other node. And as I continue to type this, it starts to provide access, or hints, if you will, to the various nodes that are connected to this network. So this can be really handy when you're developing expressions, and even more so if you have a very busy network and you start defining these names of nodes to something much more meaningful to you. They will show up in a list here, and it won't be as hard to find them. So in this case, I've put the height variable in here, and you'll see that now my boxes are changed in height. Then one more, just for fun. Actually, what I'll do is I'll elaborate on the system. Uh, right now what we're doing is just on a static piece of geometry, but what about actually copying these to a particle system? Let's very quickly create one, and we'll do that by sourcing the grid here. So with the middle mouse button from the output, I'm going to get a pop network. So it's a separate branch. Then I'm going to use the I key to dive inside, call in a source pop, and the geometry source is going to be the first context geometry. That means the first input to the popnet. I'll order the points randomly. I don't really want too many particles, so I'm going to reduce the constant birth rate to 10 particles per second. And in order to get them to move off the surface, I'm going to add a velocity, change the variance down to something small like this, and put a velocity in the positive y directions. If I run this, then I'll get particles like this. So that's good. That's all we need for here. I come back out here. If I display this, then I'll get particles. Now let's substitute the grid with the popnet. Then display this. And as we do, the box with the stamp function copies random size boxes to the particles. So it works just fine. Now, rather than switching back and forth with the inputs here, what I'm going to do is put in a switch stop. If you've followed any of my other lessons, you'll see that I use this quite often in an example. So I plugged the grid itself and the popnet into a switch, and then the switch goes in here. This way I can use the switch to move back and forth between either the static grid or the particle system. Since I'm at frame 1, there's no particles, I don't have any boxes. But I can easily move back and forth between these two. Now let's try one more stamp function. In this case, we're going to rotate. These have been all static values. In this case, I'll use a rotate function, or sorry, variable. I will use a random value again because I want the rotations to vary based on the point number. So I'll get a different rotation for each object. In this case though, in order to get a rotation, I need to actually enter a time value of some kind, so I'm going to use the frame function $f times 20. I don't want this to be too busy, and hit enter. So this is a random function again. I've added a larger value here to spread out the count of the point numbers, so I get a bit more of a variety. Then it's multiplied by a time value, and the time value is $f, which is read the current frame, times 20. Now let's add this into this field, so the X rotation. It's the same function. We still want the copy 1, comma, rotate is the local variable that we created, and I'll use 2 in here. The 2 is just a small multiplier for the value. So 1, just to make this clear, 1 essentially means there's no multiplier. It just takes whatever the value was set in here in the copy sub. So look what this does. As you can see, the boxes are rotating at various speeds. And if I switch to particles, I'll zoom out a bit. It works well here as well. So this is a very, very simple demonstration of the stamp function and how to set it up. Thank you.